After learning various terms of machines, now let us try to learn a very simple machine called pulleys. You know what is a pulley? Pulley is a circular wheel. This is a circular wheel. This is here. It is having some thickness, which we will call it. I have shown it in a very expanded way. So here there is a groove. In the middle there is a groove, and in that groove I can pass my rope. So my rope can pass through this groove, as shown here. So this pulley can be fixed or pulley can be movable. If the pulley is fixed to the ceiling or to some rod, this is called a fixed pulley, and this is called a movable pulley. Here you will see this is a fixed pulley and this is a movable pulley. Now let us try to see what are the mechanical advantage and velocity ratio in these three different arrangements. Now this pulley is a circular wheel, and on both the ends there is a frame, and in that frame some axle is passing, which fixes the pulley to the frame, and frame can be fixed here. And at the lower end also of the pulley there is a hook where I can attach the rope. Now let us try to calculate the mechanical advantage and velocity ratio of these three different arrangements. So in the fixed pulley, this is the load. If I do the force balancing at this point, then L is acting down and tension T is up. So this is my tension T. So that is my tension T. So this is my tension T, which is acting up, and load is acting down. Therefore L is equal to T. And as the same rope is passing, so tension in the same rope remains same. So here also tension would be T. So my E, if I do the force balancing at here, I will get E is equal to T. So my E is equal to T, L is equal to T. So my mechanical advantage I will get as 1. Now if this load is lifted by 5 centimeter, that means this effort, and I have also pulled it by 5 centimeter. So distance moved by effort and load are same. So velocity ratio is 1. So this you should remember that for a fixed pulley, M.A. is 1 and VR is 1. Now let us see what happens in case of a single movable pulley. Now in case single movable pulley, this is the load L. So here there are two ends or two strands of rope that are lifting this loader. So if the tension is T here, same rope, so tension has to be T here. So in this case, if I do the force balancing, so this L is equal to 2T. So in this case, L is equal to 2T. So T is L by 2, and if I do the force balancing here, I will get E as L by 2. E is equal to 2T, which is equal to L by 2. So my effort is half the load. So I may make an advantage 2. Now let us try to see the velocity ratio. If this load moves up by x centimeter, then this end will also move by x centimeter, this end will also move by x centimeter, but my rope cannot remain loose, so I have to apply the effort equal to 2x. So my effort is 2x, load is x, so again velocity ratio would be 2x upon x, that is 2. So that's what is written here, that in this case also velocity ratio is 2 and mechanical advantage is also 2. Now we are going to this case when there is one fixed pulley and one movable pulley. Now here when I lift the load L, it is again balanced by two ends. This is T, this is T. So each has to be equal to L by 2. So this T is L by 2, and if I here the same rope is passing from here, so here my effort would also be L by 2. So again I will get mechanical advantage as 2, and velocity ratio is also 2, because this moves by x centimeter here, this will move by x centimeter, this will move by x centimeter, so means here I have to pull by 2x. So velocity ratio is also 2. Then why I have used 2 pulleys when I can get the same MA and VR in this case? Here my effort is in the convenient direction. So that effort can be applied in the convenient direction, I have used 2 pulleys. Now disadvantage of using 2 pulleys is that there will be more friction, so efficiency would be less as compared to this case. Is it alright? So these are the very simple applications of pulleys. Now we are